So far, all of our rational function examples in our videos have had ends that grow in either the positive or negative direction. We want to take a look at rational functions where the ends have a horizontal behavior. Okay, so we're going to do this using end behaviors and zeros and multiplicities, number line chart. So sketch the graph using end behavior, zeros, and multiplicities. And our first function is f of x equals the fraction where the numerator is x squared plus 2x plus 1 and the denominator is x cubed plus 3x squared minus 25x minus 75. All right, so same as all of our other examples. Same process, everything. We're going to watch for holes in the graph, potentially that sort of thing. So the first thing we're going to do is, since this is not factored, it's already simplified for us, we can get our leading term. So on top, our leading term is x squared, and on bottom, our leading term is x cubed, which reduces to 1 over x to the first. So right away, this end behavior is different than on our other rational function graph videos. So we have to know that when you divide by a power of x, your ends are going to shrink. They're going to get closer to 0. And because it's x to an odd, the left end is going to be negative in getting closer to 0, and the right end is positive in getting closer to 0. So what this results in is a graph that's getting closer and closer to the line y equals 0. So we call that a horizontal asymptote at y equals 0. All right, so we're going to see that in the graph. Now, the next thing we're going to do, like we always do, is find the zeros in multiplicities, which we can get by factoring this this rational function. X squared plus 2x plus 1 factors as x plus 1 times itself, or x plus 1 squared. And on the bottom, we have 4 terms, so we'll factor by grouping. In the first group, we can pull out an x squared, leaving behind x plus 3. In the second group, we can pull out a negative 25, which also leaves behind x plus 3. We still have our 2 groups. We're not done factoring, so the top is done. I'll just copy the x plus 1 squared. The bottom, though, I can pull an x plus 3 out of both of my groups, leaving behind x squared minus 25, which factors further, so we're still not done. So on top, we didn't do anything. We still got our x plus 1 squared. And on bottom, we get x plus 3 times x plus 5 times x minus 5. Now we can see our zeros and multiplicities to put on our number line chart. We've got negative 5, negative 3, negative 1, and positive 5. So negative 5, negative 3, negative 1, and positive 5 way over here. Those are our critical values, or our zeros. And we can see that if x is negative 3, negative 5, or positive 5, they're in the denominator. So we're going to have vertical asymptotes at those 3 x values, right? And at negative 1, our numerator is 0, so we're going to have a 0 output. And so also we need our multiplicities. Negative 1 is the only guy with an even multiplicity, and the other 3 have a multiplicity of 1, so they're all odd multiplicities. And now we can use our end behavior, start getting signs. The left end of our graph is below the x-axis, and the right end of our graph is above the x-axis, so we get negative and positive outputs respectively. Now we need the signs in the middle. Odd multiplicity, so the sign is going to be different here than it was before. Odd multiplicity, we get a different sign. Even multiplicity, so the sign is the same here as it was before. Odd multiplicity, we get a different sign, which is good because that checks out. Now we don't have any holes in our graph because nothing canceled, nothing weird like that. So we can go ahead and sketch our graph. We've got negative 5 is going to have a vertical asymptote. Negative 3 is also going to have a vertical asymptote. Negative 1 is going to be an intercept. Positive 5, we're going to have a vertical asymptote. And we also are going to have a horizontal asymptote to help us with our end behavior. Okay. Now, to the left of negative 5, our outputs are below the x-axis. I know my end behavior has to approach that horizontal asymptote from below. I have to stay below the x-axis, which means as I get close to my vertical asymptote, I have to deflect to negative infinity. So let me kind of clean this up a little bit. So my graph looks something like that to the left of negative 5. Between negative 5 and negative 3, I'm above the x-axis, so I have to deflect to positive infinity near both vertical asymptotes. Between negative 3 and negative 1, I have to deflect to negative infinity as I get close to my vertical asymptote. Between negative 1 and 5, I'm below the x-axis, and I have to deflect to negative infinity as I get close to my vertical asymptote. And then after 5, I have to stay above the x-axis and exhibit the right end behavior. So I have to approach the x-axis from the positive side and deflect to positive infinity near the vertical asymptote. So my only choice is this sort of behavior. So you can see in this graph, the ends are horizontal and they're not growing up or down like we've seen in the other videos. Let's do another one. Same instructions, but now let's work with a different function. How about g of x equals the fraction where the numerator is x plus 5 quantity squared and the denominator is 3x minus 8 times the quantity x plus 7. So in this case, it's already factored. So we already know our zeros and multiplicities. So I'm going to go ahead and indicate those on a number line chart. So the x value or the critical value from top is negative 5. On the bottom, I get 8/3, which is like 2 point something, and negative 7. So I've got negative 7, negative 5, and 8/3 as my critical values. Negative 5 has a multiplicity of 2, which is even. Negative 7 and 3x and 8/3 have multiplicities of 1, which are both odd. Negative 7 and 8/3 both come from the denominator, so they're going to result in vertical asymptotes. Negative 5 comes from the numerator, so it's going to output 0. Now I need my end behavior to start getting some signs. So my leading term here on the top, x plus 5 times x plus 5, my leading term will be x squared on the top. And on bottom, it's 3x times x, which is 3x squared. And if I reduce that, I get a coefficient of 1/3, 1 divided by 3, with the x's gone. So I just get a constant leading term, which gives me an end behavior that's going to approach the line y equals 1/3. So I get a horizontal asymptote again of y equals 1/3. And I won't know if I approach it from above or below until I finish out my graph. So I'm going to leave that blank over here because I don't know, but I do know I'll be getting closer to that. So both ends of my graph will be positive or above the x-axis. Multiplicities will give us the other signs. A positive changes to a negative when it crosses an odd multiplicity. A negative stays a negative when it crosses an even. And a negative changes to a positive as it crosses an odd multiplicity. Let's set up our graph. Labeling our critical values as always, negative 7, negative 5, and 8/3. Vertical asymptotes at negative 7 and 8/3. Intercept at negative 5. Horizontal asymptote at y equals 1/3. Label 1/3 on the y-axis and draw the asymptote in on the ends because that's where our graph's going to approach. All right, let's work on graphing this guy. On the left, to the left of negative 7, my outputs are above the x-axis. I have to approach both asymptotes and stay above the x-axis, so I have no choice but to do something like this. Between negative 5 and negative 7, I have to stay below the x-axis, so I'll deflect to negative infinity as I get close to the vertical asymptote. Between negative 5 and 8/3, I'm below the x-axis, so I have to approach my asymptote towards negative infinity. And to the right of 8/3, I'm above the x-axis, and I have to approach both asymptotes, so my graph's going to do this sort of thing. So there's an example of a rational function whose ends are horizontal, but they're not approaching the x-axis. They're approaching the line the horizontal asymptote y equals 1/3, not y equals 0. So your horizontal behavior could be anywhere along the y-axis.